How you doing? Welcome to live stream number 73. It is 2 p.m. Eastern. It is October 10th, 2017. Thank you so much for taking the time to join today's, just have to check my mic is on, to join today's live stream. Today's topic is 3 reasons why joints are better. Better than what, you're asking? Well, if you have never used any other CAD software, don't worry about it. But if you're like me, coming from another CAD software, so like Inventor, or you're coming from SolidWorks, or one of the other major parametric pieces of software, there is a couple of things you need to know about joints inside of Fusion that might even maybe blow your mind. You let me know. You see, we already got Tommy in here. Really appreciate it. So, we're going to get into talking about joints. And do me a favor. Just, if I do a good job explaining this, give me a thumbs up. If I don't, be honest, give me a thumbs down. Because I think that this is an important topic. I get quite a bit of emails from people who are confused about joints. So, I'm not going to build this up to like a big drama kind of thing. I'm going to give you the 3 things on top, and then we're going to dive into them. Number 1, joints eliminates degrees of freedom better. 2, joints, I should have like drum roll or something like that. Joints are not the last thing you have to do. And what I mean by that is that if you've ever used constraints or mate in either Inventor or in SolidWorks, you know that they come in the end. You definitely would never consider doing those quite early on in the process. And the third is that joints are linear or flat, meaning that you can actually do some neat things with them that you cannot do with the other tools. So let's jump into it. Let's get into Fusion and play a little bit around with joints. So the first one is that if you are if you have used Inventor or if you use SolidWorks in the past, this should look somewhat familiar to how you join or mate components together. So in the other pieces of software, you're kind of like removing degrees of freedom. So let me just explain that first of all, how this works. And Bryce, who's sometimes joined the live stream in here, was the one who kind of like explained this the best way to me. So with Inventor or with SolidWorks, you're kind of removing the degrees of freedom of how you're putting things together with these constraints or with these mates. So you're kind of like removing 1 degree of freedom at the time, where with Fusion, with the joints, you are doing 1 joint and then you're removing the degrees of freedom. So if you're looking at this model here, and we're taking this block that I have right here, and we wanted to mate or constrain to this kind of like L channel right here, what you will do with standard CAD, like Inventor or SolidWorks, is that you would mate this face to maybe this face, and you will kind of like create a linear or planar constraint between those two, a mate between those two. Then when you have done that, you will go over and you will do maybe a mate between this surface and this surface, and then you will kind of like see how now you kind of like have a sliding action doing this L channel here. And then maybe finally with the third mate, you will do this face to this face, right? So that's how you would do it normally if you're coming from another software like Inventor or SolidWorks. Now, I want to show you how you do it inside of Fusion, and then I'm going to talk a little bit more in detail about it. Check this out. I'm going to go in here. So what I want to do is I want to finally end up with this block laying in this end channel planar to this face here. I'm going to do a joint. I'm going to go over to our component here, and you see how I get the little coin that shows up here. That is actually a coordinate system. We'll talk about that in just 1 second. I'm going to snap to this corner and click once. That's component 1 selected. I'm going to go over and I'm going to find the same corner over here, and I'm going to select that. And just with those 2 clicks, I have placed that component where I really originally wanted, where with the other software, you would have used 3 mates to be able to place this. Now, so here's the trick that Bryce taught me. So with the other ones, you're kind of like doing one face at a time to eliminate or to kind of like take away the degrees of freedom. With Fusion, you start out by applying all the constraints, and now you can loosen it up. So after I now place this, I can go over here and I can hit the drop down, and now I could decide that I want to do it as a slider, for example. Now it will start to slide, right? So I'm loosening that degree of freedom, and I can then control around what axes, right? So now I suddenly have that sliding motion that I want. I could also go in and I could do a revolute around one of these. So originally, let me just cancel out of it. Originally, instead of going in and say, made this face to this face, then made this face to this face, and then made this face to this face. That's your normal Inventor SolidWorks. You're kind of like taking 1 degree of freedom away. The way you do it in Fusion is when you click here, when you hover over, you get this coin, and it has its own coordinate system. And literally, you snap it to one intersection, you snap it to another intersection, and boom, you got the same results as you will do with all the other with all the 3 other mates that you see inside of Inventor or, for example, SolidWorks. Now, you get some added ones right in here, right? So I just placed those 2 corners. I can go in here and I can now start offsetting, right? You will see how I can grab the handles, or I can type in over here, whatever you kind of like want. So that's kind of like an offset. So I think that this is probably, if you're coming from the other software, the biggest thing that you want to wrap your head around is that with Fusion, you do 1 joint, and that will do it rigid, and then you can start letting go of your different constraints, giving up of the different constraints. So if you've really been struggling a lot with this whole concept, that is the first piece that you need to get with. And the reason the reason that it is rigid is because 90% of all mates, joints, or constraints that you're putting in on your models are really what you are getting for is a rigid joint that can't move around. So that's why it's picking that first. Now I wanted to come back to the coin that you see. So when you hit the joint, you get that half moon coin, whatever it is. So this has its own coordinate system in it. That's what it's placing on the model. And you will see that when you hover over a face, you kind of like get some dots on that face that it will snap to. So you can either snap to the midpoint of this, or you can snap to like the end point. You can snap to the corners of the blocks. It's kind of like broken down like this. Now, sometimes when you're trying to pick something, you will see that it kind of like flips direction when you're trying to do that. Here's a trick. If you hover over the face and you hold down Control or the Command key on your Mac, Control on Windows, it will now stay to that face that you did it over, and it will not snap to any of the other faces. So let me go down on this face here. Right now I don't hold anything down. It can kind of like flip whatever it wants. If I hold down Control on my Windows machine, you will now see you kind of like locked that down, okay? So that's the trick when it comes to really mating within Fusion 360, is that when you hit that joint, find the corner that you would like to lock it down, or the point that you would like to lock it down to. So for example, this corner here, and I want to click on that, I get a new kind of coin lining up on the second component, and those two will now match up whenever I select down here and place that where I want it. Now I also wanted to show you that with a round cylinder type, so when I go in and I hit a joint here and I hover over a round, you will see that I actually get 3 places by default. There's top, it snaps to the middle, and it snaps to the bottom here. So you get those 3 options right off the bat to snapping this into. So if I go down and select the bottom here and click once, and now I can go over to the round hole, and again, if I hover over the face here, if I hold down control, then it will actually snap into the same one, the top, middle, or bottom, right? So if I, for example, snap it to the middle here, you will see it's going to come over, and it automatically is going to give you a rigid, because it takes those 6 degrees of freedom and tie it all down to 1. Versus the other software where you kind of like got to do it one at a time. And now I can let go. So if I know that this is going to be a cylindrical, I can go down here in the drop down and select that, and I now have that movement that you would expect. So that is the first thing that you, hopefully, if you're coming from one of the other softwares, really, that was for me, but was like, wow, that was what I needed to know, how this works. So instead of degree that you have to remove each degree of freedom one at a time, with Fusion, the first one does it all for you, and then you let go of them. Now, another thing that you need to know is that these coins that you see showing up when you are in here, the coin that hovers around, if you don't have the coin that you would like to get, let's say that I kind of like wanted this one a little bit over here, in the drop down you can create your own joint origin. So if I click on this, I can actually create my own origin in here, and now you will see that I can place it to this edge, and then I can place that some certain distance. So if I know I wanted that 1.5 inches away from that face, I have just created my own origin that I can now, when I go into the joint, I can now snap to that. So that should really get, I would think, a lot of people's question out of the bat about joints. Rewatch it again one more time if you need to see it. But that should make cleared up for people, I hope. You let me know. Thumbs up, thumbs down. If you don't, then we'll just try again. But this does make you be able to add joints a lot faster than in the old-fashioned way, where it's kind of like first this way, and then you got to do it to another face, and then the third face to put it in like that. That was reason number 1. Joints eliminate freedom right out of the go. Number 2, joints are not the last thing that you have to do. So this is interesting. You can start adding joints a lot earlier to your design that you maybe, if you ever come from another software, that you ever thought of. And I give you a little bit of a background about that. So Inventor, and I'm saying Inventor and SolidWorks just because that's the 2 products I know and I used a lot. So in Inventor and SolidWorks, you gotta go back to like the late 90s when those softwares was kind of developed, early 2000s. And when they started out with a part file. That was all you were worrying about. You were going from 2D to 3D, right? And all you were kind of like worrying about in the beginning was how can we create a cool 3D model? Well, then of course there was somebody who said, well, I need to be able to assemble them into one thing. So that was when you created a assembly file. So that's, if you're using some of those 2 systems, it's 2 different things. You have a part file over here, and then you create an assembly file over here. And then you bring the part file in to the assembly file. That is called bottom-up modeling. And that was kind of like how it all started out. And then when you got it inside of your assembly file, then you had to kind of like tie things down. That was where mates came up, right? Now, later on, they did start doing top-down assembling inside of Inventor and inside of SolidWorks. That kind of breaks the rule a little bit, but still the same thing when it comes to the mates, where you put them on in the end. Because if you don't, well, they were not really designed not to And if you don't, then many things blows up. Let me show you something cool. Something you maybe have never seen before. I'm going to start a brand new file here. And I'm just going to create 2 components. So let me right click, because that's where joints works, is with components, right? So I'm going to create a new component, and let's start a sketch here. And I'm just going to hit the S key and draw something up here. This is not really important at all. I'm not even going to fully define it. I'm just going to create a block like this. So that is model number 1. And then I'm going to go in and create another component. New component. And that's going to be model number 2. And we're going to do the same thing. We're just going to go in and create a 2 rectangle or 2 blocks. It doesn't get much simpler. Let's make that a little smaller. It's not going to get much simpler than this. So we got 2 components, right? Now, we normally want, inside of an assembly, we normally want to ground one of them. So you hit ground, so one of them is kind of like stuck. So now, if we go up to the main assembly up here, now this one can move around. This one is stuck. You can actually also use joints for that, but that's another live stream. Here's something that some of you guys might just hold on to the table for a second. So what I'm going to do now, I got 2 components in here. What I'm going to do now is I am going to add a joint to this face here, right? To this face, right on this edge here. And I'm going to go and I'm going to apply a joint down here. And right now it remembers that it was cylindrical we used before. I'm just going to make it rigid, okay? Nothing too crazy about this. We have these 2 parts are now joined together. Anybody who ever used Inventor or SolidWorks, all good with this. But check this out. What will happen now if I go in here and I create a fillet on this edge? You tell me. Well, it appears like nothing is happening. Let me just repeat that fillet and select the other component too. Now, this part here is still joint. How can that be that I just blew up those 2 edges with those 2 on it, and this is still sitting in place? Well, if you have ever used any of the software, you're asking yourself, but this is one of the great things. This is one of the advantages with Fusion being a newer software and not from the late 90s, early 2000s. The reason is, as you would have guessed, that the joint is happening before the fillets in the timeline. Now, if you have never used any other CAD software, this doesn't really, you're saying to yourself, well, that's what I expected to do. It happens before the fillet, so of course it should be joined. That's the way it should be. But if you've ever used any other CAD software, you know that joints don't work like that. Like, that's not how they fit together. See, inside of Fusion, there's, a part file lives inside of an assembly file, and an assembly file lives inside of a part file. There is no part file over here that's got it wrapped into an assembly file. It's the same environment, and that means that the joints, the way the code is written, the joints literally follows the timeline. What means that you can start adding joints to components right off the bat. You don't have to worry about adding the details later on in your model. So you can literally, if you know the 2 parts has to fit together as a slider, for example, you don't have to think about like a channel, piece of aluminum channel that's got to fit within another sliding thing. You don't have to model each component up down to the detail, then add the joint. You can literally do it from the get-go and then start adding all your cuts and fillets and all the other stuff later on, and the model's not going to blow up because the joint is not sensitive like it is in the other software. That's number 2. So think about that. next time you start modeling, that you can actually add that in there. That's kind of cool. The third one is that joints are flat. And what I mean by that, I kind of talk about that a little bit. I talked about that a little bit earlier, that in this case here where we saw how they are following the history tree. Let me show you something that I hope some of you guys will get something out of in a way to model up. I need a sip of water. So let's open up another design here. And I'm actually not going to create the component first. I am going to just go in here and sketch a rectangle up. Hit the S key, and I am going to do a rectangle. I'm going to make it 4 by 4, and I'm going to extrude this out. If I extrude this out right now, then what I have now is I have a body. Bodies are great. They're very powerful, and you can definitely use these. Especially if you're like working in kind of like figuring things out, they're great. But of course, components are the ones that's going to show that, first of all, joints works with components, but it's also what's going to show up like on your bill of materials for your drawings and things like that. But I'm actually going to use this box to kind of control my whole assembly with. So just to make it a little bit easier so you don't have to fight this body all the time, I'm just going to go in, and if you right click on the body, you can actually change the opacity. So I'm just going to make it somewhat so we can still see it, see through, because that's going to kind of drive all my components. So now I'm going to go up and right click, and I'm going to say I'm going to create a new component. So now I have a new component here. We have our body, but now we have a new component. The face eye is turned on. I'm going to open up a sketch on that body, and I'm just going to do an offset right of this edge here. And I'm just going to offset something in here. Let's do it minus a ½ an inch. And I'm just going to create a couple of lines on this box. Okay. Something like this here. Okay. Now I'm going to go in and hit Q to extrude things out here. And if I go in here to press pull, and I pull this one out, 300 thousandths. Now you will see over my extrude menu over here, it is doing it as a new body. Right now I'm just going to hit OK to that, just to show you the difference. My sketch goes away. Okay, let's get back. Let's go into the sketch back on here. There we go. Now, if I do the same thing again, extrude out, and do the same thing, 0.300. Now be aware of that from in here, you can actually create components. So I'm going to create a new component from in here. And I wanted to show you that because I want to show you that you can create new components within. So right now we have like this component, and these are now becoming subcomponents to this component that lives inside this component. Now you can always right click on a body, and you can also turn that into a component. So now I'll just turn the first body we created into a component. So be aware of how we can do that. Now I'm going to continue doing this 2 more times. So I'm going to hit Q and do the press pull. I'm going to make it 300. And again, I'm going to make a new component. Hit OK. Do that again. Repeat press pull. 300,000. And say I'm going to create a new component like that. So now I kind of have this body that is guiding everything. Let me turn that off for a second. And then I have like these 4 components sitting right here. Now, what I'm getting to is right now, these components can float around. Like I drew them up, but they are components, so they move. Oops, they move around, right? Now again, if you're coming from either Inventor or SolidWorks like I do, this is when you will start kind of like trying to maybe join things, to make things together. So I showed you before how we can do the joints and how easy it is with the coins showing up. But there is actually also an option in here as build joint. And it is really it does what you think it would do, in the matter that I don't have to move the parts around. I can just go in here, click on As Built Joint, and I'm going to select one component, select one other component, and you will see how it defaults in to just create a rigid joint between these two components. Now I could go in and change to something else, but rigid is actually what I kind of want here. So I'm just going to hit OK to that. I can continue that process. I can make this one here, this one here. I can make that rigid. Right click, repeat, build as joint. I can go in and say this component and this component I want to be rigid. So I'm just creating those joint with that built-in joint as you saw before. So you had the standard joint sitting up here, same thing here. But then this built-in joint is absolutely awesome if you draw things up like I kind of did with this picture frame, where I want it as these component, but now it shows up and I have all joined them together just like that. The last thing you will see in here though is that this thing still moves around because I joined those components together, but you can't actually see if I move this one over and I turn the origin on. There's the origin for the original body we created. You can actually also do build as joints between components right inside of the assembly here. So you can kind of like move things around like that. Okay, I hope that so there's the joint with the little coin you're moving around. Now I just showed you the as-built joint. So if you model everything up, everything is kind of like together. You kind of have that in there. And now I want to show you another cool thing. Let me turn that body back on that we kind of like originated the whole thing from. Now, if I go over to our sub-assembly over here and hold down shifts, select all these components down here and do a Control-C, Control-V for a window command, you will see that now I'm actually just copying all those components that I had, right, from 4 to now 8. So you can do that. You probably have maybe already seen that. So now I'll just create a copy before. Now, but at this point, you will see that now this one, I didn't take the joints with me. These are only the ones that is joined. These are still floating around. Now I could do the same thing as I did before. I could go in and say, repeat the as-built joints. But there's another command you need to know about. That is called rigid group. So where the as-built joint will create a joint between each component, where you can control if they want to be rigid, if you want them to be sliding or cylindrical. The rigid group is really just like we added some glue to all these components together and hit OK. So, for things that never going to have a real function as be able to, slide around or interact, rigid group is another alternative that really just works as everything is glued together. And now I can do what I did before. I can either go in and hit a standard joint, and I can place a joint coin up on this component and go back over to our modeled box and bring that one over. And now I have 8 components. But what is neat about these 8 joints or 8 components is that they are all driven by that original sketch that we created first. So if I go in here to our original sketch 4x4, if I go in here and I change this one to 8, you see that everything is parametrically joined like this. I'm hitting up on the half an hour. I only got one more thing I gotta show you. It's gonna take you 2 seconds. So I really hope that this is I hope this is useful because what this gives you an option to do is to create I created a body up here, right? That body up here with one rectangular sketch, but created the windows frames around it, and everything is still tied backwards to that original sketch. So, these joints don't have to happen all at the end. They can be in the beginning, they can be around, and you can still do that. Now, the last thing I want to show you, so let me just save this assembly here, whatever. Let's open up our panel here, and let me go and make that sub-assembly active for a second. Now, remember that box we've been working with the last few days? Let me right-click and insert that into the current design. So that's going to come in. I'm saving and bringing that in. That's a little bit out of proportion. That's fine. I'm going to bring this in here, and I'm just going to place it in here. Now, so let me just make things a little smaller in here. So we have our original assembly up here. Then I created a sub-assembly, and inside of that sub-assembly, we have all these components that makes that kind of like that picture frame. And we also have this linked in box that I just brought in. Now, one thing I'm going to do to this box, now it's still linked. I'm going to go down to the bottom. We did this when we made this box before. And we're going to right click and we're going to ground this just so it's ground. So it's kind of like sitting inside of this. Now, if you've ever used Inventor or SolidWorks, check this out. If I grab this lid, see what happens? Normally, when you bring a sub-assembly inside of another sub-assembly within an assembly buried down in the tree like we have over here, it comes all in rigid, right? Because it can't, how can this file solve a joint that exists in a completely other file? Normally it takes, you got to kind of like make them be able to do this. By default, Fusion can do this. And this is one of the advantages of having, newer development who can kind of like rethink how we are working with software. So I hope this was useful. Right 2 minutes over the normal time. So just to recap, if you're brand new, if you came in a little late, if you're coming from another CAD software, what's the beginning where we're talking about how joints takes care of freedom right at the go. So if you have struggling mating things together inside of Fusion because you're coming from Inventor or SolidWorks, make sure you check out the beginning. Remember, joints are flat. You can literally start using them a lot earlier than you can do later. And then in the end, I hope that this kind of like gave you a little bit of an insight on how you can kind of like work with this. One dimension is suddenly, or the dimensions on the box suddenly are controlling that whole picture frame moving around. That was what we were planning on showing today. I hope it was useful. You let me know whatever you think. Be honest. And if you haven't already, of course, appreciate you'll subscribe to the channel. That's where we're going to end it. I'm going to end the broadcast as I normally do. So if you're watching the recording on YouTube, thank you so much. And for you guys who are in the live stream, I'm going to come in and say hi to everybody. Thank you so much. I hope I see you tomorrow.